Hey everyone, so I'm gonna go ahead and go over my code for the replication. I'm gonna go ahead and load in all these packages right here. And for this instance, I'm just gonna start with page 60. So right here we're loading the URL into the object, and then right here we're reading the URL as an HTML, and then I'm putting it back into the same object. And as you can see, it's reading it. That's why you'll see the stop symbol. Oh, timed out. So this is a pretty common issue. Let's see if we can change our location. Alright, I'll be operating from Austria. Cool. Oh, yeah, so operating from Austria reads the URL just fine. So we see that, if you're scraping a particular page way too often, the server will actually throttle your speed. And that's why you'll get these timeout warnings right here. Next, I'm going to go ahead and run these two lines of code. So this first one, it's going to go ahead and look at this object initial URL. And if I look at it right now, it's this stuff. You can't really read it. I'm going to go ahead and specify which class we want to look into. So entry content contains the summaries for each post. So I'm going to go ahead and specify that. So I go ahead and put period and then entry content. And I also want to scrape the tags for each post. So I'm going to go ahead and put period, tag links. Alright, and then now that we've have them put into these individual objects right here, so sum and foot, we have, 10 different posts here. But we still need to make sense of it. So we're going to go ahead and run those same objects and specify to read it as text. And then when we do that, let me go ahead and open sum again. Oh, there it is. So if I try to read this object, this is what I get. So now we're seeing actual text right now. So this is the first post, second post, third post. Now I'm going to go ahead and read those objects and convert them to data frames. Great. Cool. Alright, now we're going to go ahead and run this for loop. Since I started with page 60, next page is page 61. And then basically this function right here pastes those numbers in, reads them in one at a time. So we'll go ahead and does the same exact process, but just loops through. So let me go ahead and run that. And this should take a little bit of time. If you're not sure if the function is still running, if you look right here, there'll be a symbol that pops up that says stop. This option only comes up if the function is still running. Great. So it ran it just fine. You'll notice I have some warning messages right here. These warnings are associated with a previous scraping that I did, so you can just ignore this part. But this is basically just history from the catch that this trying to bind, but is not there. So I'm going to go ahead and see that we have two different objects now, right? So sum 1 is right here now, and we have 1,000 observations. It's because each page has 10 posts, so 10 times 100 pages. equals 1,000 observations. So if we open this up, we'll see each individual summary, right? Same deal for the tags. So if we look at foot 1, there's also 1,000 tags. And we'll see each tag for each post. Now we don't want them to be in separate objects. We're going to go ahead and use cbind and put them into one object. We see that both of these are together now. Great. All right, so right here we're going to go ahead and just rename each column of our new object called complete, summary and tag. So if we go ahead and look at complete, summary tag. Great. All right, now you'll see that in the summary tab, summary column, we had to do a little bit of cleaning. So when we're trying to do natural language processing, it's common just to get rid of punctuation. So things like commas or parentheses, we want to get rid of all of that. So I'm going to go ahead and run this function to try to get rid of most of the punctuations. You'll see that, not all of them are right here, but this is just the first round. So I go ahead and specify which column I want to run the function gsub on. So gsub is going to look for all these different punctuations and substitute it with an empty space. Then we go ahead and look at our data frame again, and we do a quick check, and we'll see that it does a pretty okay job, except for things like this or this, right? So it didn't catch all of them. Whatever we don't catch in our first substitution, we'll go ahead and run another function later to get everything else. Now we can also see that our tags are considered as factors. We don't want to do that, so we're going to go ahead and run the ask character function to read them as characters. And there they are. They're characters now. Cool. All right. Also another problem in the tags column is that we have the word tags. We don't care about the word tags. We only care about everything else, right? So we're going to go ahead and run this function right here, remove words. So it's going to remove any word or anything within this quotation mark. So tags, this thingy, I forgot what it's called, and the space, right? So it's going to remove everything there. And if we look at that object again, it's gone now. There's no more tags. Those two little dots, that space, they're gone. Okay, so we see in the website that each individual user, the tags that they put in, they actually have a lot of autonomy over how they name their tags. And we want to specify, we want to look at posts only related to the workplace. So we look for words like workplace or capital W workplace, office or capital office. Any one of these tags, I want them to basically make a new column called work and put work into it, the word work into it. So if you run this function right here and we open our object again, we see there's a whole another column, and basically whenever workplace, something, any one of these four words pops up, it's gonna add the word work into that column, right? Workplace, workplace, work, workplace, and a quick visual check, and that is correct. Cool. All right, now it's gonna go ahead and basically only grab only grab the observations that have work in it. So if work equals work, so if there's a work in this column right here, it will select the summaries. And I'm going to put it into this whole new object right here called work summaries. And if we look at that new object work summaries, it only grabbed the posts that had the tags related to the workplace. And we see there's only 231 observations in this case. All right. Next step is that we're going to go ahead and take that object, vectorize it, and then put it into a corpus format. And then I put it into an object called textdoc. Now I'm just going to go ahead and convert the text all to lowercase, because we don't want the word so, a capital S-O, and the same word so, lowercase s-o, to be considered as two different words. We want them to be considered the same word. So we're going to go ahead and run this line right here to convert the text to lowercase. You're going to get this warning right here. Transformation drops documents. That's fine. Don't worry about that. I'm going to run this next line again, and this removes common English words. So things like and, but, the. And then I'm going to go ahead and run this extra line of code to remove additional words. So things like work, like, don't, just, didn't, really, job, I've, make, made, one. They don't really add anything to our analysis. We're going to ahead and remove them. We go ahead and remove the numbers. We go ahead and run this line again to further remove other punctuations that we might have missed earlier. And then we're going to remove all the extra white space. Right. Now we're going to run this line to do some text stemming. Right. So try, trying, tried, all gets reduced to try. T-R-I. All right. And then now we are on our way to making it into a text matrix document. All right, now that it's in this format, a document term text, document term matrix, we can finally fit our model. So in the assignment, I specified that just use 5 topics. So I go ahead and specify 5 right here, starting with the C, 1, 2, 3, 4. And then this function basically fits the model on 5 topics. Oops. And this basically just says this model has 5 topics, right? And now we're going to go ahead and use the tidy function, take those word associations and put them into a matrix. And then we'll go ahead and run this line right here to grab the top 20 word associations with each topic. All right, and then now we're just going to go ahead and visualize it. Great. Now our results are right here, so we're going to zoom. This is our first, second, third, fourth, and fifth topic right here. Now you see that we'll have some problems like quotation S, this line right here, this weird line, this, I don't know what that is, it's kind of blurry, but other punctuations that we weren't able to grab the first time. So text is a very weird thing. Even though we specify, even though we know to get rid of certain punctuation marks, R won't do that. This is the first topic is time, get, manage, man, try, woman, way, even, never, female, start, men, tell, colleague, friend, where, year, around, don't. So this is the point really where your judgment comes in to try to determine what each topic actually means. You're gonna have, it's not enough just to read the 20 words associated with each topic. You probably have to read all the other words and try to discern, distinctly what does a topic have that another topic doesn't have. That's where you come in. Good luck, guys, and I hope you enjoyed this little exercise, and hopefully you learned a lot. Thanks.